All right, so the first problem we have, well, in all of these you're asked to find y prime, but it starts with y equals 4 cosine x to the fifth multiplied by the natural log of 6 minus 4x. I get students are starting to ask questions like, how do I know which rule to do first? Should I do the chain rule first, or should I do the product rule? Or and those are hard questions to answer. I guess when I see this, the first thing that goes into my head is, well, I've got the product of two functions. Now, within each of those functions, I will need the chain rule, but not yet. Okay, so the first thing I do is apply the product rule, and so that says I'm going to leave the first one alone, and I'll multiply by the derivative. I'm not even going to calculate it yet. I'm just going to write it out by the derivative of the second one, which is going to look like this. And then I'll do the derivative of the first one. And I'll just then multiply by the second function left alone. So by no means am I done, but I think that's a good first step. So this is like, I'm breaking it apart. This would be the first thing I would write. Now, this problem has turned into, hey, just find this thing in yellow, and then find this thing in green, and you'll be all done. Then you'll be all done. Once you find those pieces, you'll just plug them back in, and the problem's done. So, as far as this piece in yellow goes, well, that looks like I need the chain rule. Right? So that's going to be 1 over 6 minus 4x multiplied by the derivative of 6 minus 4x. And then what's the derivative of 6 minus 4x? Negative 4. So that purple box is just negative 4. So that piece in yellow really turned into negative 4 divided by 6 minus 4x. So that was, I just took this negative 4 and I multiplied it by this fraction. So that's like negative 4 over 1. So when you multiply fractions, you go top times top and bottom times bottom.
Where did the 6 go in the purple box?
So in that purple box, that says the derivative of 6 minus 4x. So when you see 6 minus 4x, there are two terms. Okay. So the derivative of 6 is 0. The derivative of minus 4x is a minus 4. So
Gotcha.
instead of writing 0 minus 4, we just write
I was only focusing on
minus
the
4.
derivative of negative 4x.
So we've got the yellow piece. This needs to get substituted in for the yellow piece up above. Now we just have to tackle that green piece. So I'm going to scroll down.
That's so cool.
So we're just going to do a bunch of work right here to find this, and then we can go back and plug it in and clean this up. So I see a couple different things going on. I got an outer function, that function that's to the fifth power, so I'll start with this. So it'll be that times the derivative of what? Good. And then inside the red goes what? Okay.
What kind of rule is this?
So chain rule. So I just wrote out the chain rule. So we got the derivative of the outer multiplied by the derivative of the inner. And then this piece here, this isn't so bad. You can actually rewrite this. This is 4 times the derivative with respect to x of cosine x. I just actually got to move the 4 out front. So, and that, like, the reason I'm able to do that you've got this property that says the derivative of a number times a function is equal to the number times the derivative of the function. I probably does. I don't know it.
Oh yeah, we'll keep
That's not even product. I mean, that's just,
that is.
you could prove it with the product rule, yeah. So anyhow, we can back up here. Turns out that green thing is, well, we got to do this. What's the derivative of cosine x? Negative sine x. So I'm going to write 4 times negative sine x as negative 4 sine x. So this has got a little bit of a mess here, but I have 5 times 4 cosine x to the 4th times negative 4 sine x. Or, I don't know, I guess you could do it as negative 20 4 cosine x sine, 4 cosine x to the 4th. Sine x. No, I mean it's as far as how I grade it, it's easier if you don't, but just there's a real quick one you can simplify it that way. So our whole green piece is, let's say it's this one right here. So we got to go back up. So we'll go back down. So are you fine with what I highlighted in green there?
I have one quick question.
So let me get this one first.
Okay.
So, I mean, Nick, I can't touch any of the stuff in here because it's to the 4th power. But, you know, this is all multiplication, so I can reorder multiplication however I wanted to do it. So I just stacked this negative 4 right next to this 5. And then I turned it into negative 20. So I moved it from right here. I said, why don't you just put it out front? That's negative 4. Negative 4 times 5 is my negative 20. Well, I mean, it could be, but it's attached through multiplication. So just like if you had A times B times C times D, well, C and D are certainly hooked up through multiplication. But that doesn't mean, I mean, you could move C out front and write this as C, A, B, D.
Oh, never mind.
Yeah, you could. So you could write it as a negative. Yeah. Yeah. Yeah, you could, yep, you could move this one out right in here too, or even out in front. What other question do we have?
Never mind.
Okay, so we're back here, and I think we just need to do a rewrite of this. You know, swap the yellow piece for the yellow and the green for the green, and then we will be done. So I've kind of got a mess here, but we'll try it. Okay, so see, I don't need this. I can make space there. Okay, so I'm just going to actually erase this, yellow, and then in parentheses, I'll put in this negative 4 over 6 minus 4x, and then erase the green and substitute. Yeah, I could have done that too. Yep, still realizing that these two could be put together for a negative 20. Oh, I missed one parenthesis, didn't I? So that's the first one. This is your answer. We'll just we'll highlight it in blue.
That's so freaking
That's a lot. You have to. I don't know. I think some of you are a lot smarter than I am. You can do it without breaking it up. That's the answer. Yep, that is
We,
work to get the answer.
well,
the derivative of that. That's y prime.
we go back down to the bottom.
Ask questions along the way here. So the second problem, we had y equals e to the 5x sine of x times the natural log of x. You're going to say, I don't really have a product rule for three pieces. Well, what you're going to do is you're going to say this is one function and this is another. So, sure, you can do the other way. So, can you find the derivative of the orange function? Yeah. And then the purple function, when you go to find its derivative, what rule do you need? Product rule. So the product rule happens twice. So you end up with e to the 5x times the derivative sine x times natural log of x plus the derivative of e to the 5x times sine x natural log of x. So I'll give you a sec to process and ask questions.
Could you pair?
Yep.
Could you pair the sine x and the e to the 5x?
Yeah, you could do that.
Could you show us what you did that?
Do you do product rules for inside sine x times
Uh-huh.
log natural x? Like, are you doing product rule twice for this?
Yes. So okay, so like if I said, okay, you've got the orange. So
Are the things underlined purple because they both have eggs?
no, they're. I could put them together. You can put them together however you want.
So you could have done e to the 5x
And sine x, that would have been fine too. Yep, we could actually do that as well. So I've only actually, I mean the product rule right now has only shown up once. But you've got, like let's say, if I said you have function orange and function purple, you're going to multiply them. Okay, I want you to find the derivative of function orange times function purple. You'd say orange times the derivative of purple plus derivative orange times purple.
So you're gonna have to do double derivative of purple,
Well,
essentially.
yeah, I mean when I get to finding the derivative of the purple piece right here,
I mean, you're gonna find the derivative of that too. You do product rule.
Yeah,
And then double derivative of sort of in a weird way. Don't say double derivative. Okay. so
Don't
you
say
have to
double,
like-
that's weird.
Sorry, I'm trying
Okay.
to like, say my own words.
here we go. So shh. Okay. The product rule happens twice. Okay. Okay.
Product rule happens again. With
All right,
highlighted
let's do that one. The derivative of e to the 5x. What is it?
E to the 5x.
E to the 5x times 5. Okay. Now, when you get to the purple here, oh, it just so happens the purple is the product of two functions. You're going to need what rule? Product rule. Okay, so you'll go sine x times the derivative of natural log of x plus the derivative of sine x multiplied by what? Natural log of x. Okay, so this thing here is how much? 1 over x. Okay, so you got sine x times 1 over x, which should be sine x over x. And then this one here, how much is that? cosine x, so you got cosine x times the natural log of x. So it turns out that purple piece is this right here. Okay, that's going to get substituted in for purple. We've already said what's going to get substituted in for yellow. So if you just plug those components in, you're done. So we're gonna do that real quick.
How powerful is that mic? Like, can it hear what I'm saying right now?
Whoa.
Yeah.
Really? I'm a part of the video.
Shh. All right, so you gotta just plug these in. So this purple gets erased, and we're gonna plug in this one. Oh, that'll do it. Sine x over x plus cosine x ln x. And then the yellow gets plugged in, and that was e to the 5x times 5.
How are we supposed to know that e to the 5x, I mean the derivative of e to the 5x is that yellow? I
Well, you got two functions. You got an outer function of e to the x. The derivative of e to the x is itself. So you recopy it. And the inner function is 5x. Its derivative is 5. All right, next problem. So problem 3. A little bit different. You got x, y to the 9th plus pi minus 4x cubed y equals xy. The goal is to find y prime. Y isn't isolated. It's going to be tough to isolate it. But you can differentiate before you isolate y. It's called implicit differentiation. How many terms do we see? You just have to do the derivative of each term. Okay? So you're going to do the derivative of the xy to the 9th term. This is kind of a nice one. What's the derivative of pi? So that'll be 0. That's not bad. And I'll probably go with I think the rightmost one is the easiest to do. Well, aside from this. Okay, that's 0. I'd go to this one next. What rule do you need? Product. So you're going to go x times d dx of y, which is called y, which is y prime, plus the derivative of x with respect to x times y. So Nick, well, this is why I'm writing this. This dy dx, another thing we write for dy dx is y prime. So this is really xy prime. What's dx over dx? 1. So plus 1 times y. So this is xy prime plus y. And that's going to go... So this is this. So we've got a couple more to do. You've got this... let's say you got this yellow one. What rule do we need? Product. Yeah, and there's some chain rule going on here. So you got x times the derivative of y to the 9th plus the derivative of x with respect to x times y to the 9th. This thing here is how much? 1. So this is 1 times y to the 9th. This thing here is what?
9y prime.
Careful.
38.
9y to the 8th times y prime. And don't forget to bring this x down. So this is the yellow thing. And then we got one more. You got the green one here. product rule. So you got your 4x cubed times the derivative with respect to x of y plus the derivative with respect to x of 4x cubed times what? Times y. Good. So I'm just writing out the product rule. Okay, what do we call that? That thing that I boxed in orange? That's y prime. Okay, so you got 4x cubed y prime plus, anybody know what this is in green? 12x squared. Okay, so 12x squared y. So we've got them all highlighted. Now we need to plug them in. The last step is going to be to isolate y prime. So let's see if we can. So I don't need this middle stuff. So now I'm just going to make the substitutions.
Are we gonna have problems like this on the assessment?
Yes.
More so than the first step?
You'll have the first, so this learning target is about implicit differentiation, combining rules, and logarithmic differentiation. On the assessment, you'll probably have one of each.
Do we have to plug in y? Or are you gonna, did you make us do that?
Yeah, you'll have to plug in y.
So you have to find what y is also?
No, you're not gonna. Sorry, you're not gonna have to go back and solve for y.
Okay.
So this thing you guys said was 0. The green piece. Notice, hey, subtraction comes before this green highlight. So whatever we substitute in, we got to put it in parentheses. And the last is plugging in the yellow. Okay, now I'm gonna erase the 0 because it's not needed. But if I,
What are we left with then? Plus or minus?
yeah, what are we gonna be left with? That was my question for you guys. If the 0 goes away, it'll be a minus. Okay, how many terms do you see?
I only see 3. Or, I mean,
6. We should really distribute this subtraction. Okay, so this would be 9x y to the 8th y prime plus y to the 9th minus 4x cubed y prime plus, minus 12x squared y. How many terms did we say? 6? Okay. How many terms have y prime in them? 3? Okay. So those 3 terms need to get put on one side of the equation. You want them on the left or right? I'm going to go with, I think left just because there's 2 on the left already. So this guy here's got to move over. This one's going that way. And this one's going that way. So if it is positive, when you move it to the other side, the term will become negative. If it were negative, it's going to become positive. Okay. So I'll just do the left side first. 9x y to the 8th y prime minus 4x cubed y prime minus x y prime equals y minus y to the 9th plus 12x squared y. Matt, now what do I do to the left side? So right there, each term has a y prime. So you're going to factor it out. So what's left in the first term after y prime comes out?
9x, y, 8.
Okay, the next one. Good. Cassie? Or who had their hand up? Somebody had their hand up, right? Oh, okay. Okay, last step. Divide, okay. Y prime equals that mess divided by so there you go. That's the third problem. Implicit differentiation.